Alright, ladies and gentlemen, the first page of these notes are just review of last night's video, the video for the first day, and that's just review of first semester, and it's combining like terms. So when we say add or subtract polynomials, write your answers in descending order. Remember, that's basically like standard form. Largest variable term first. So if it's subtraction versus addition in between these, that's the only difference. When it's subtraction, you're technically distributing a -1 to the parentheses after, so that changes the sign of everything. Instead of a +6, it becomes -6. Instead of minus 4x squared, it becomes plus 4x squared. But nothing changes in that first set of parentheses, 7x squared plus 12. The difference in the addition is you're distributing a +1, which means absolutely nothing changes. All of that stays the same. You have positive 9x squared, that stays the same, plus 2x stays the same, minus 1 stays the same, and likewise, the first set of parentheses stays exactly the same. So the only other thing to talk about with this section is the descending order part. I like to look at this as far as like terms, find the largest exponent term first. In that case, it's x squared. There's no other x squareds. So I have -7x squared. The next is my x term. Oop, and I screwed that up. Good catch. So I actually had two x squared terms, and so I can combine those to get -7 and +4. Gets me a -3x squared. And then I have a +12 and a -6. That gets me a +6 for my solution. These aren't like terms. I'm done. The descending order plays a bigger role in number 2 because I have an x cubed term here, but no other x cubed terms, and I did not make a mistake on that. So that's 10x cubed. Then I go to my next largest exponent, which is a 2. I have a plus 2x squared, a plus 9x squared, and those are my x squared terms. I'm going to write that one next. Plus 2 plus 9 is plus 11, and those are x squares. Remember, combining like terms, exact same base, exact same exponent, and you keep those the same. 11 is a constant, but I also have an x term, so I need to include my x term next. That's descending order, 3, 2, exponent of 1, and then finally I can do my constant terms, which I have a -11 and a -1 as my constants. When I combine those terms, I get a -12. Exponent of 3, 2, 1, no exponent. That's descending order, and I'm done. Go ahead, press pause, take a moment, and try the other problems on this page. For number 3, x to the 4th plus x to the 3rd plus 1/12 x squared minus 9. Remember, adding fractions is not bad as long as you put it in your calculator. Your calculator will simplify them. You can do a math frac to get your simplified fraction. Make sure you put your parentheses around your fractions. Number 4 is just a straight up addition problem as well. Since it's just addition in between my two addition problems in between my 3 polynomials, combine all your like terms, you don't have to change any signs. For number 5, you have to change the signs for the 3rd polynomial because that's the subtraction one, but not for the 1st or the 2nd. And when we finally combine the 1st polynomial, 2nd polynomial, and the new polynomial for the 3rd one, 9x to the 4th minus 3x to the 3rd minus 7x squared plus 6x minus 17. And again, the order does matter. Descending order means by exponent. 4, 3, 2, 1, nothing. Now, we've been using this word a lot called polynomial, and we haven't really completely defined it, so we're going to go ahead and define a polynomial. A polynomial, by definition, is just an expression, and it's an expression typically that has multiple terms. Terms are separated by addition and subtraction. So polynomials can be classified two different ways. We can classify it by degree, which is going to have to deal with the exponent, or we could classify it by term, which is, again, separated by addition and subtraction. So it's saying how many times are we adding and subtracting. So let's go ahead and go through the actual names here and kind of define what those are. When we are classifying polynomials by degree, we're looking for the largest exponent. We're not looking for all of the exponents. We're not looking for one of them in particular, like the first one, the largest one. So as I go through this, I look at my list. In this polynomial, the largest exponent is 4. I have a 4, a 1, and that's an exponent of 0. So the largest degree here, the largest exponent, is a 4. And then likewise going through, I have an exponent of 3 and 2. 3 is the largest, only an exponent of 2. This is an exponent of 1. Remember, if I have a variable with no exponent written, the exponent is 1, and when I don't have a variable at all, that's an exponent of 0. So we would say that these polynomials have those degrees, degree 0, degree 1, 2, 3, and 4, likewise. But we have more specific. Degree 1 is what we studied the vast majority of first semester. Those are our linear functions, graphs that would be a line. Degree 2 is what we've just kind of started and just wrapped up studying, and we'll be doing a lot more of. When it's x squared, it's second degree, or it's degree 2, and those are called quadratic. Degree 3 is called cubic, and degree 4 is called quartic. And we could continue going on, but at some point it doesn't matter much to us in Algebra 1 what we call it, and we would just say it's a 4th degree polynomial, 5th degree polynomial, 71st degree polynomial, and so forth. Now again, when we're classifying polynomials by term, our main focus is how many times we are adding or subtracting. So a term is separated by addition or subtraction. So there's no addition or subtraction here. That means it's just one term. Every time I add or subtract, that gives me another term. So I had one term, but then I added another term, 2 terms there. Addition, addition, there's 1, 2, 3 terms. And then addition, subtraction, subtraction, there's 1, 2, 3, 4 terms here. But again, just like with by degree, we don't classify them by a 1-term or a 3-term polynomial. We have very specific names. When it's one term, we call it a monomial. 2 terms, and we'll study these a lot in this chapter, are called binomials. 3 terms, we'll study these a lot as well, are trinomials. And then again, once we hit 4 terms, 5 terms, there does become a point where are there names? I'm sure there are. But in our Algebra 1 class, we're not going to necessarily need to know the specific mathematical names. So for now, anything beyond these first 3, a monomial, binomial, or trinomial, we'll call by the number of terms. In this case, I would call it a 4-term polynomial. If there was 5 terms, 10 terms, I would use this same terminology. Alright, so let's go ahead and let's write down the classifications by both degree and term down here. And generally that is the order in which we would do this. We would be degree first, term second. So just to pick out a couple that I'll do with you, this first one, by degree I'm looking at the largest exponent. The largest exponent is a 1. Well, when the largest exponent is 1, it's a first degree or a linear polynomial. But there's also no addition or subtraction, so it's only one term. So it's called a linear monomial. And that's what we would call this. Just to pick out a different one, let's say I did part F. The largest exponent here is a 2. That makes it second degree, which makes it a quadratic. And it has 2 addition signs, so it has 1, 2, 3 terms. That makes it a trinomial. So this one is a quadratic trinomial. With that said, I want you to go ahead and press pause. Try to come up with the two names for all of the others on this list. Press pause and go ahead and fill those in, please. Alright, so we have a cubic trinomial. 3 is the largest exponent, and there are 3 terms. Quadratic binomial, largest exponent of 2, 2 terms. Largest exponent of 3, 2 terms. Cubic binomial. No exponent at all makes it a constant. Only one term makes it a monomial. That one tends to be tricky. Quadratic monomial, one term, but exponent of 2, look at part I, is a cubic monomial. Largest exponent of 3, one term. And linear binomial, because that has an exponent of 1 here, that makes it linear. Alright, the last thing for these notes is just complete review. I'm not going to review this completely. I'm going to do 2 problems again with you. You guys are going to do the rest and get practice. This is going to be really big for your video tonight and for what we're going to be doing next week. But first, distributive property. I'm going to do number 2. This is something times the parentheses. That's when we distribute the entire thing. I think I have to do this with you because I have to review this concept. If I'm taking 6x and I'm multiplying it by 2x, plus I'm going to take the same 6x and multiply it by 3. Really massively important concept here. I cannot stress this enough. That's x times x. X times x gets you x squared. 6 times 2 gets you 12. Do not miss that. That's really important and tends to get missed. The other thing that tends to happen is people make this, they get the 12x squared, and then they just say, oh, that's 6 times 3 is 18. Don't forget that when you're distributing 6x here, it's not just 6. You're distributing the x, and you need that in there. Those aren't like terms, so I can't combine. Then to do number 4 with you guys as well, it's the same concept, except now I'm distributing 2x to the third to here. So that becomes 2x to the third times x squared minus 2x to the third times 2. Notice I am distributing and I am writing this whole line out. That's not 100% necessary, but that prevents me from making the mistake I was just talking about, forgetting to combine my exponents here, forgetting my exponent here. Okay? The coefficient is 2, the coefficient is 1, that gets me 2, but if I have x to the third times x squared, that's x times x times x times x times x. So remember our exponent properties. Add my exponents. 2 bases, add my exponents. X to the 5th. 1, 2, 3, 4, 5 x's. Minus 2 times 2 is 4. Keep x to the third. Now I'm done. Go ahead and take a minute, pause, and try the other problems on this page. So for 1 and 2, or 3, 3x squared minus x, if you have 1x, that's fine. 2x to the third, because this is x to the second times x, plus 4x squared, and I forgot the x squared, and there's another concept that we always forget. In 5 and 6, once you distribute, you then combine like terms. And be careful, in number 6, I'm not distributing x, I'm distributing minus x. So negative x times 4x is negative 4x squared. Negative x times 2 is minus 2x. And then my like terms, but right in descending order. And finally, once again, we have to make sure that when we distribute, we don't leave anything behind, and that we combine our like terms when we are done. Okay, at this point I want you guys to make sure you watch video 2 for tonight. Coming into the next class period, we will have to have had that watched, and we are going to continue multiplying, but now we're going to start doing the distributive property at more than once in a problem.